Hello and welcome to SudoKanard, another high pointer from the latest Sudoku Grand Prix by Can Erturan again from Turkey. And this is a mix of diagonal Sudoku in which both main diagonals must contain all digits exactly once, and Thermo Sudoku, where on each thermometer digits increase in the strict sense starting from the bulb end. It was worth 85 points, and I remember having some sticky moments, I would say. Well, the beginning, it will be obviously with this big thermometer, where the minimum value here is 1, 2, 4, 3 is not available, 5, 6, 7, and 8. But you can see that 8 is not only the minimum value, but also the maximum because of this line. So those min-max values can be confirmed. Oops, that's a 5, that's a 4, and 3 is not available. So that's a 2, and that's a 1. So this part is an easy part. And I'm seeing that 1 on the diagonal must be in this area of the grid, which means one of those two cells. Now, what about this part of the thermometer? This has a minimum of 2, 3, 4, 5, so there are lots of options, except that this can't be a 6 or an 8, so it must be from 5, 7, 9. This can't be 7 or 8, so this is from 4, 5, 6. This can't be 5 or 6, so this is 3 or 4, and this is 2 or 3. So not that many possibilities. Is there anything more about this thermometer? Something interesting here is that 1 is not here, so 1 can't be anywhere on this thermometer. It's not here because of those pencil marks, so we get a 1 somewhere in there. I'm also seeing that 8 and 9 by some standard classic Sudoku reasoning is here. In these cells we get 1, 6, and 7. This is not 1, this is not 7. We need 2, 3, 4, 5 in here, so those are from 2, 4, 5. 2, 3, 4, 3, 4, 5. 1 is not in here, so 2 cells. I'm not sure that this is really useful. 6 is not here and not there, so we have 3 cells for 6 in this region. There again, not sure that this is really useful. 1 is here in this area. What are the possible values here? 3, 5, and 9, I think. Yes, that is correct. What about this thermal? So this is a minimum of 2, 3, 4, 5. So, oh, but this has a minimum of 4, but a maximum of 5. It can't be in a 9, and it can't be any of those digits. So this is 4 or 5. This is less interesting. This is 4 or 5, so this is 3 or 4, 2 or 3 here. And I'm afraid that there are many options for this digit. Well, at least 5. I'm seeing 8. We get an 8 in here, but because of this, it's not here. And because of the 8 on the diagonal, that is an 8. And my Sudoku places an 8 here, which resolves the 8-9 pair here. Now this is from 4, 5, 7. This is from 4 and 5. This is from 1, 4, 5. And this from 1, 4, 5, 7. So not that interesting. This column needs 1, 2, 6, 9. So this is from 2 and 6. 1 and 2, because there's a 6 here. And actually, this is the only place for 6 on this column. This is from 2 and 9, from 1, 2, and 9. So this is just slow progress. If we know those 2 digits, then we will know all of those, and this will be the smallest. This can still be a 7, in which case this is 2, and no, in which case this is 1, and this is 2. I'm not sure I can do anything with that kind of information. Well, where is the next place to look? There will be an 8 somewhere here. Oh, where is 8 on this diagonal? Not here, not here. It must be here. And we get an 8 in this cell. So we have all 8s in the grid. And what about 5 on the diagonal? Lots of options. Now this is really not an easy puzzle. There has to be something about this. 7 is not here. 6 is not here. 5 is not here. So this has a maximum of 4. So we have 4, 3, and 2 here, and this is a 1. And here we're left with 5, 6, and 7. So 5 or 6 here, 6 or 7 there, and 5 or 7 here. Which implies that 2 in this area is in one of those cells. We can remove the 2 from this cell and the 1 from this one. Here we have a 3, 4 pair, which could be useful. On this row, 1 is not here, 1 is not there, so 1 is here. And the remaining digits here are 2, 7, and 9. So this is from 7, 9, this is from 2, 7, 9. All right. So about this Thermo, I'm not sure I can do anything more. But oh, this 4 resolves this, that's a 5. That's not a 5. And this is from 6, 7, 9. So this diagonal still needs 1, 2, 3, and 9s. Oh, and 1 is not here, so that's a 1, that's a 1. So we still need 2, 3, and 9, so this is from 2 and 9. And we know that one of them will be a 3. 4 is not here. Not here. We have a 4 somewhere there. And on the diagonal, 4 can still be here or here or here. Not that interesting. This 6 is not here, so those are from 2, 5, 7, 9. That's a lot of pencil marking. This region has the 1 on this cell. I've been missing this. Well, the thermal part is basically done. We're left with this diagonal logic. There's still quite a number of digits to place on this diagonal. And this has a lot of candidates. What about this row? This row still needs 1, 2, 3, 4, 6. There's a 3 here on the diagonal, so this is not 3. 1, 2, 3. So this is 4 or 6. 1, 2, 3, 1, 3. So this is from 2, 4, 6. Lots of options here. Oh, we still need a 1 in one of those cells and in one of those cells. We still need a 5 somewhere here. Somewhere here. That's a lot of possibilities for 5. What about this region? We still need 2, 3, 4, 7, 9. So this is from 2, 3, and 9. I'm looking for some kind of diagonal Sudoku logic. I'm saying that on this diagonal, 9 must be here or here. So this cell can't contain a 9. It must be from 3 and 5. And this still has a lot of options. I'm wondering whether I will have to use some classic Sudoku technique. I already solved this Sudoku, but it was quite a while ago, and I don't remember what the high points were, the most difficult steps. Yes, oh, by the way, that's not a 2, which is quite interesting. Now we have a 3-9 pair. This is not a 9. And the remaining digits on the diagonal must be 2, 4, 5, 7. There's a 5 here, so this is from 2, 4, 7. And that's interesting. On the diagonal, 5 is somewhere here. So that's not a 5, and this is not a 5, which gives a few digits. And there's something here. Yes, there is something, probably several things. One thing I'm seeing is that in this box, 4 is in one of those two cells. And in both cases, if 4 is here, then there's a 5 there. If 4 is here, then there's a 5 there. So at least one of those cells contains a 5. This is called W wing, I think. So this cell and this cell can't contain 5s. And now we get a 3-4 pair here, which resolves that. That's a 2, that's a 5, and that's a 4. And this here is a 5. And this 4 gives the 3 here. Those are not 2s. This is from 7, 9, and the 5 on this row is here, which gives the 3. Oh, what a chain reaction. That's a 3, which gives the 4 and the 3 and the 4 and the 5. Up there we need the 4 and the 9, so this is 9. This is 4, it gives the 2 and the 3. And we also get this 7 and this 2, and this 7 and this 9, the 2 and the 9. This row still needs 6 and 9, so 6 here, 9 there. That is a 4. 6 here gives the 7, the 6, 1 and 7. There we still need 6 and 7, so 6 and 7 like this. There's a 4 here, so that's a 2. That's a 6, that's the 4, that's a 6. Here I need a 1 and a 9. And this is 5. This is 4, this is 2, and this is 3. So this was a pretty difficult puzzle. All the more so that at some point I had to find this W wing. So you may wonder how I found this. So there's a way of finding those. So I will just backtrack to the moment I found this, which was here. So when I found that those were 4 and 5, I just had a look at this. So this is a way of finding W wings. So if you have a disjoint pair, you would say, I mean, no, that's not, no, remote pairs. Identical pairs, 4, 4, 5, 4, 5, but there doesn't seem to be any relations between them. But, so this is in this row, this one is in this row, and they are in different boxes. And you look at the third row and the third box here, and you can see that in those sets you have a 5 but not 4s, which is the way of finding out that 4 is somewhere here and that one of those must contain a 5, which yields what I just found, what I just explained in this video. So thanks for watching. See you soon on SudoKanard.